Okay. Do you have all your people here?
Yes, yes. Not yet, probably. I'm not sure.
Well, we can start.
Starting.
Please turn your volume up. You're very low.
I'm trying. It's better now.
That's better.
Good.
Yeah.
Very
Okay.
good. Well, welcome. I know it must be what, but it's about 10 o'clock there, or 11 in Poland.
Yes, it's 9 p.m.
9. Okay. Well, welcome. Hopefully next year you can meet here. We have 15 minutes, so we can probably jump right to some questions. Let's see. Why don't we just go around? Bob, why don't you ask one, and Logan ask one, I'll ask one, and we'll keep going around that way. Okay. So Bob, why don't you start?
First of all, I just wanted to make a comment that I was very happily impressed that you had PR and marketing as one of your sub teams. It's, as they say, no bucks, no Buck Rogers. It's an important part of engineering that other teams don't often include in their plans. I just want to ask about the roll control canards. How did you come up with that design decision, and what are some of the I don't know, maybe just challenges you faced in implementing it?
As for the decision about the canard fins, we considered like RCS system or canard fins, and basically that's the two options we thought about. And the canard fins are much better in the lower atmosphere, so we chose this. The whole architecture of the system, or just a decision about the control surfaces?
Yeah, you could just talk about the details of how did you choose the control surfaces, and maybe what control law you're using for the active control.
Okay, so as for the fail-safe mechanism, we were wondering how to make it, and we wanted to make it the simplest possible design. So we decided to use the springs to get the fins to the neutral position, and we tested it in flight, and with proper fins, the fins are stable. They basically don't move. When there is no control from the servos, they don't move, so it is flight proven right now. I don't know what else can I say. As for the control, we didn't have a flight test for it, but we want to control it from the onboard sensors, accelerometer, magnetometer, and gyroscope. Get the orientation of the rocket and control the orientation of the rocket.
Do you use just like a PID controller, or what the control mathematics?
Probably we will use the PID controller, but we aren't able to do it this year. The next year, probably this will be implemented. And the first step is to reduce the rotational speed of the rocket. Probably PID will be the best for the beginning. Later on, we want to implement the Kalman filter.
Great. Logan, you want to go ahead?
I'm going to pass for the moment.
Okay. Let me jump in there then. Could you discuss your float system for figuring out the level of the nitrous is very impressive. It's very innovative. What materials are you using, and what sort of materials compatibility issues did you think about when you made it?
So yes, this system is, we tried to do it the easiest way as we thought it would be. And so it's just tennis balls, normal table tennis balls. It's connected with the structure printed with ABS. So, and the one problem which we had was the glue for the parts. to stick together, because glue with nitrous oxide, different types of glue with nitrous oxide can just unglue themselves. I don't know. I'm not sure why is that. Probably by oxidization. So we stick to the we decided to use just a mechanical connection, and it's done by some rods, metal rods, and it's working. It's working fine. We have no problem with it. We didn't test it fully. We tested for in oxidizer, but only gases, in gases state, and on the water to just see if it's just working fine.
So you've actually already tested it in nitrous then once?
Yes, but just only we tested if it's capable to endure the pressure.
Ah, okay, okay. So the materials, the balls you use and all the printed materials, they're compatible with nitrous oxide then, or an
Yes.
oxidizer?
Yes.
Okay, good, good, good. Let me ask you, how did you clean your system then? Not only the whole system, but this float system, how did you clean that to ensure you have no contamination in your nitrous oxide?
Mm-hmm. We use it with air, but compressed air, and we are able to, by those holes which are drilled in this tennis balls, we are able to pass the air, so we are sure that it's clean inside.
What did you do any like soap and water cleaning or any cleaning like that with chemical cleaning to ensure you've removed all the residue and it's clean?
I mean, we did, we not yet, but we will maybe try to clean it with acetone or some other alcohol to make sure it's clean inside, and
Okay.
alcohol will vaporize.
Do you have any way to inspect it once it's clean?
Not yet.
Not yet, okay.
We'll think about that.
Okay, I would recommend you use a UV light. If you get a UV light and a way to look inside of there to look at the fluorescence, that would be a good test.
Okay. Okay.
Okay, very good.
Yeah.
Okay.
Yeah, it's really, really important to remove all greasy, oily residues, anything in a nitrous system.
Contamination can be very bad. It can blow the system up. That's
Yes,
why we're very important on that. And I think you know that. That's nothing. You worked with nitrous before, so you understand how important it is. Okay, good.
I had another question related to the float system. So the float system basically relies upon a density difference between the liquid nitrous and the gaseous nitrous on top of it. Could you discuss that relative to what if the nitrous started to get close to its critical temperature?
Yeah, we'll try to not to get to this point. I mean, we are able to control the pressure and the temperature inside the oxidizer tank, so we are pretty sure that it will not get to those limits. Yeah, so we don't think it's. I mean, even if it would get to this level of pressure,
it's a good question. What would happen if it got to that level?
Yeah, probably it would not work. Yes, but we would just dump all the oxidizer if this situation would happen, because we won't. It's not the proper filling process if the pressure is in such high level.
Great.
Okay. Good. Let's see. Let me think. Have you had any hot fire tests yet?
Of the propulsion system, yes.
Yeah, the propulsion. Have you fired your system yet?
Yes. We had one test, but only for it. It was on 1 kilogram of nitrous oxide. It was our first test, and it works perfectly fine. But in one place of the hydraulic system, we had too small diameter for nitrous oxide, so the maximal thrust was 1,800 newtons, so a little bit below what we expected, but we fixed it, and we wait for another test in near future.
Well, do you expect to test sometime when school starts?
No, I mean, I think in 2 weeks, maybe.
Oh, 2 weeks. Oh,
yes,
great.
yes. We are ready for it. We have our grain, so we have not need nitrous oxide, so we are ready.
Very good, very good. I saw your when you did your you pressure tested your oxidizer tank. Let's see. Did you use water or nitrogen to pressure test that?
Water and oil to just. I mean, inside the tank is water, and in the hose is oil.
Oil.
Yes.
Okay. Okay.
Let's see. You had wireless communication with your rocket, right? Or wireless communication between the different boards on the rocket. Is that right?
Yes. We have two ways of wireless communication. One is LoRa module, which is for long-range communication between our main computer system in rocket and our ground station. And inside the rocket, to avoid long wires going of the full rocket structure, we have implemented wireless system using XB modules, which are good for transferring data for short distance.
Great. Could you talk a little bit about whether you've taken any actions regarding cybersecurity with your wireless system, or if not, just sort of talk extemporaneously about issues that you might want to address?
We didn't think much about the cybersecurity, but both LoRa and XB could be set in encryption mode, and then all the data sent will be encrypted, but of course the transmission would be a little bit slower.
That's fine. That was just kind of a think on your feet question.
What? Let me jump in. How many students do you expect to have on the team come the fall? Do you have any? Are all of you near? I don't know. Are you spread out over Europe, or are you all near your school? Or how many you expect to have students will be there in the fall on your team?
Well, we already have like 60 members of ours, and I think we expect about like 20 maybe new people, because maximum 20, yeah. We have like some sort of test for verification of our students, but we think that the best thing that we can get from someone is that he will have the will to work, and not only the abilities, because that's what you can get with working with us, but when you want to work and you are passionate about it, that's what we are looking for. So I think maybe like 20 new members will be just fine.
And there are 60 already on your team?
Yes, 60 already.
How many seniors and juniors, or fourth year and third year?
I think like 20 seniors and like 40 new members we get this spring. So it's like like more than a half of these students we have is like new people that still learning, but it's really fun to meet new people that have like share the same passion what you share. Yeah.
Wonderful, wonderful. That's impressive. Well, that's good to see your team is very active and alive. I've never heard of anyone giving when the students come in, they actually train them. That's good.
Yeah.
That's very good. Good. Keep it up. That's a good way to
Yeah.
keep them going.
Thank you. Thank you.
Let's see. We've got another minute or two. Let's see.
I don't have anything more on
You don't have anything more?
questions I'd
I
written
don't know.
down.
Logan, you got anything you want to throw in?
Yes, I'm curious about the airspeed sensing system. Has that been built? Does it actually exist?
The question is about parental module.
Yes.
That module has been built and was tested, and the pressure is measured correctly and sent wirelessly to main computer.
Okay, how did you test it?
We tested it in our rocket, not in that rocket which we are presenting now, but we have some kind of smaller rocket for tests like that. And about 2 weeks ago in Poland, we have occasion to launch a smaller rocket and test that system.
Excellent. Very good.
Nice.
Well, ladies and gentlemen, that's the, you used your 15 minutes. I've been very impressed with you guys. I hope you can see many of you next year in New Mexico if the situation allows. So good luck and be safe. All right. All right.
Thank you.
Thank you very much.
Thank you very much.
Thank you very much.